just to go over your Lyme Regis field work. So I'm going to first of all just go over what we did, and then we're going to have a look at some questions and see how we can apply our knowledge and our understanding of our field work to exam questions. So probably the most important bit to start with is the title. So our title that we were looking at, our main title, and this is the one you need, is Lyme Regis affected by coastal processes? And this is something you will need to write in the exam. It will ask you to write the title. So that's what you write. We then had two sub-questions. Does longshore drift operate on the beach and in what direction? And is the beach affected by erosion? So that was our first bit. We then need to look at our location. So our location. So we went to Monmouth Beach in Lyme Regis. It's 38 miles south of Street. Why did we go there? The exam will always ask you why. They will never ask what. So here, why did we choose to go here? Well, first of all, it was close and easy to access. So that meant that we could get there and back and do our study in one day. It also had plenty of facilities, making it accessible for everybody. There was parking, there were toilets available, and perhaps most importantly, it had a wide pebble beach. If we were going to study longshore drift and erosion on the coast, we needed to have a beach so we could measure all of those things. Then we need to look at the risks. So what were the risks? So one of the biggest risks was drowning. How did we get over that? We had to stay 5 meters away from the sea. We could have got lost. So we overcame that by staying in groups. And there was the slip, trips and falls on the beach. And again, we reduced the risk by telling you to come wearing sturdy footwear. We do a risk assessment to make sure that everybody is safe and we can carry everything out safely. Then we come to the data collection. So this is what did we do? And again, they won't ask you what did you do? They will ask you why did you do it? So the first thing we did was a field sketch. Why did we do a field sketch? Well, it was to remember what the beach looked like. It was very visual and it allowed us to compare to other data. It was also easy and quick to do, and that's quite important when we're talking about why we do particular things. It was easy and quick to do. The problems with our data, this data collection though, was that nothing was drawn to scale. We didn't go out and measure anything, so there was no scale. We also didn't use any colour. It did allow us to draw arrows and we could label and add the things that were important for our project to it. The second thing we did our beach profile. That's where we had the ranging poles and we measured between, and we used a piece of equipment called a clinometer. I will just write that in here. That's what we used to measure the angle. That was the little blue plastic thing that we used. We did a sample every 50 meters. So it's a systematic sample every 50 meters. It's quite important to remember. The reason we did a systematic sample was it was quick and easy to do, and it allowed us to measure most of the beach in the time we had available. We did this to see if the beach was changing shape or steepness, and then we could look to see if that had anything to do with longshore drift and erosion processes going on. The problem with it was the equipment we used wasn't particularly good. So the clinometer was simple and easy to use and quick to use, but it wasn't particularly accurate. There were also accuracy problems in terms of human error, reading off the values. The third thing we did was we collected our pebble size. Again, we did both a systematic sample and a random sample. It was a systematic sample because we sampled every 50 meters. It was random because when we chose our pebbles, it was chosen randomly. That was to reduce bias. Why did we do a sample? We didn't have time to sample the whole beach. This method was quick and it was simple to do. But there may have been some bias. We may not have been completely random in picking the stones. And again, there may have been some human error in terms of measuring the pebble size. We then look at the data presentation. So what did we present, or how do we present our data? Again, we've got the field sketch. It was visual, we could compare, but there wasn't any scale, so it was slightly inaccurate. We then did a beach transect. That was where we drew our axis and we used a protractor to draw the shape of the beach like that. Again, it's very visual. It allowed us to compare quickly and easily how the beach changed in terms of its shape and steepness. But because we only did 4 sites, the comparison wasn't totally valid, and they were quite difficult to draw. They weren't easy to draw. We then drew a dispersion graph for our pebble size. Again, it's visual. It was easy to do. It was easy to compare. But there may have been some inaccuracies with plotting. And again, there was no relation to the location on the beach. So we just had 4 graphs. We didn't have them in order. We perhaps should have done more of a located graph instead, so that we could see where exactly on the beach each of these had taken place. We then move on to our analysis again, and just going through, this is quite a quick section, is our field sketch. It was widest at the cob, which proves that longshore drift moves from west to east. The cob was where we sat to draw the field sketch. The transects showed us that the west side had a more destructive beach profile and it was steeper. This suggests that there's a lot more erosion going on there compared to the east at the cob, which was much more gentle, suggesting that we've got more constructive waves and the beach is being built up. We then analysed our pebbles and we did some central tendency measures. We did a mean and we did a range of pebbles, and we found that at the western side, that was the far end of the beach, the pebble sizes were much larger than at the east end. Again, this suggests that pebbles are being moved from west to east by longshore drift, and it's suggesting that as these pebbles are being moved along, attrition is taking place and the pebbles are getting smaller. We then have our conclusions. So our conclusions, let's move it over here. We go back and we answer our key question: is Lyme Regis affected by coastal processes? And our conclusion, we can definitely say yes, it is. The pebble data, our field sketch and our beach profiles all showed us evidence that longshore drift is moving from west to east on Monmouth Beach. We can also say that yes, the beach is being affected by erosion. We saw that on the field sketch, and our pebble sizes, as our pebble sizes got smaller as you move from west to east. Then we need to think about evaluating our project, and 2 key words here in terms of the evaluation. The first one is how correct is it? So the accuracy is how correct is our project. And we know that with our clinometer, there were problems with human error. So it wasn't totally accurate. We also need to think about reliability, and this is perhaps a slightly easier one to do, is we only did a sample, we only measured 4 sites. So we might have missed something. We don't know what the whole beach was like. We were only there on 1 day in May. What would the beach have been like if we'd gone in November? And maybe to make it more reliable, we should have gone on more days at different times of the year. So there we are. That's our Lyme Regis case study for that. And now we're just going to have a look at some questions to see how we can now put this into practice. So here we go. Oops, sorry. So here we go. So this is what you will see. It will say, write the title of your physical geography fieldwork. So we write, is Lyme Regis affected by coastal processes? We do that. Our first question then is, suggest why one set of data you collected may not have been accurate. So again, we bug the question. So suggest why. We've got to explain. And we're looking at data collection may not have been accurate. So remember, accuracy if we go back here, accuracy is all about being correct with our data. So if you want to stop the video and have a go, it's only 2 marks and it's 1 set of data. So here we go. Here's one I did. I just picked the beach transept. So it wasn't totally accurate because we only did 4 sites and there was some human error using the clinometer. So that meant our data collection wasn't totally accurate. Okay, the next question then says, identify one potential risk. So our bugging the question, identify. Identify just means sort of state, pick out. One potential risk, and note it says 1 in bold, and explain how the risk was reduced. And again, 3 marks. So we've got to pick a risk, and then we've got to explain how the risk was reduced. So if you want to stop the recording and have a go. And here was my answer. So my risk was the slip, trips and falls, and how the risk was reduced. So you've got 1 mark for knowing the risk. So that was 1 mark there for knowing the risk. You've then got a 2nd mark for knowing why it was a risk, and 1 mark, sorry, for how we could reduce it. So that built up your 3 marks on that question. Okay, our next one, and I just sort of doctored this a little bit because you will in the real exam be asked about your human geography as well, which we haven't done yet. So again, title of the fieldwork inquiry, is Lyme Regis affected by coastal processes? And here we have the question. So it's assess. So our bugging the question is assess. That means how good is it? And we've got the suitability of the location, and it's 6 marks. Now for 6 marks, we really need to be making 3 points, and we try and get a conclusion in as well. So assess the suitability. We're going to say what was good about the location. You can just do the whole 6 marks on what was good about the location. You might want to put in a negative as well, though. It didn't matter. So if you want to stop to have a think and have a go, please stop the recording, have a go. And here was my sort of plan for how I would do it. So it was close, so it was very easy to do in 1 day. That's why it was a suitable location. It had a pebble beach, so we could gain a lot of evidence. We could collect data, we could pick up pebbles. And the beach was large enough to collect sufficient data. It wasn't just a really small beach. It wasn't only 10 meters wide or 10 meters long, sorry. It was a sufficient size. However, it wasn't totally suitable because there were some risks with the slips, trips and falls. And because the beach was a decent size to collect sufficient data, it was also big enough that we weren't able to survey it all. And so overall, it was mostly partly suitable. You make the decision on that. Level 1 marks is where you just said what or where. So you said where you went, and so you said you went to Dorset, you visited Lyme Regis. Level 2 is you're putting in some why. Why did we go there? And level 3, which is your 5 to 6 marks, again, you've explained why in detail. So you didn't just say it was close. You said why was that important. You didn't just say it had a beach. Why was having a beach important? They also like to make it relevant to your project, to your inquiry. So talking about the Pebble Beach, for example, talking about it was only 38 miles south of Street. And the last bit for that top is the evaluation. Was it overall, was it suitable? Okay, and then the last question here, I'll just cover up that for a minute so we can look at the question. Again, here we go in terms of bugging our questions. To what extent? That is all about the how much. How much did the data collected allow you to reach conclusions? So it's asking you, how good was your data? And again, 9 marks, we need to be making 3 points. The 3 spag marks means you need to be writing in full sentences. You need to try and use some key terminology. So the question's asking, how good was your data collection for meeting your questions or for answering your main questions? And so here was an answer that I did. So I was said, yes, when I collected my pebble size, it was really useful because it showed us that the pebble size did decrease as we went from west to east, showing us that longshore drift did occur on this beach. It was really helpful because it allowed us to reach a valid conclusion. We did get evidence to support our hypothesis, but it wasn't totally reliable because we only did 4 sites. We only did a sample. There may have been some inaccuracies with measuring. Then go on to the beach transect. The beach transect was really helpful. The beach transect showed us how the beach shape changed. It was very helpful because it did give us evidence that longshore drift is occurring with the beach profile changing from west to east, from a destructive to a constructive beach profile. However, there were inaccuracies with using the clinometer and reading the clinometer, and it wasn't totally reliable because we were only there on one day, at one time of the year, and we only did a sample of sites. And then you say overall, the data collection was mostly partly useful in reaching valid conclusions. And again, the mark scheme, level 1, which in this case is 1 to 3 marks, would be very much what you did. So yes, it showed us that there was longshore drift, or you just repeat your conclusions. Level 2, which is 4 to 6 marks, you start to say why. So why was the data helpful? Why did the data collected allow us to reach conclusions? And then for level 3 is adding that extra detail. They also like you to add evidence in. So when you're talking about the pebble size, for example, up here, you can say because at the west it was 75 millimeters on average, whereas in the east it was only 43 millimeters on average. So add in some data, add in some evidence. They like that. And of course, make sure you evaluate all the time. This last question is always going to ask you to evaluate.